Hello U12, welcome to the second of our revision videos for topic 2, the network concepts, and doing multiple choice questions 5, 6, 7 and 8. Okay, so question 5 and 6 both relate to this network diagram, and I'm just going to switch over to the fact that we're looking for an Eulerian trail. What criteria need to be satisfied for an Eulerian trail? Well, firstly, a trail, no repeated edges, but the vertices can be repeated. So I'm going to put that here. Repeated edges, not allowed. Repeated vertices can be. At an Eulerian trail, uses every edge of a graph exactly once. Every edge once. It also mentions here the fact that if the graph has a connected graph, and has exactly 2 vertices with an odd degree. So if there's no points, no vertices that are outside of the network, so it's connected, and 2 vertices with an odd degree, exactly 2. Okay, well let's do the degrees first. 2, 2, 4, 3 and 3. So we've got 2 with odd degrees, so an Eulerian trail is possible. Okay, so we're going to see which one of these satisfies all this. No repeated edges, can repeat vertices, and every edge must be once. Okay, A, E, D, B, C. So we're starting with A, and we go to E, then D, then B, and then C. Well, we haven't repeated edges, and we also haven't repeated vertices, but we haven't covered 2 of the vertices, so that's out. Okay, let's get rid of that. Let's try the next one. E, D, A. We're starting with E this time. D, then up to A, B. Oh, can't get from... That's not possible either. Can't go from A to B without going through D or something else. Okay, next one. A, starting at A, going to E, then D, then C, B, D. D is a vertex we've hit already once, so that's allowed though. Looking for edges, repeated. After D is A. That's okay. And the last one is back to E. I'll use this one. Okay, every edge is covered, and it's covered at least once, and vertices has repeated, so I'm thinking that one is the one. Just going to double check with the last one, just in case. E, D, C, B, D, C. I can't repeat vertices. Repeated vertices, sorry, can't repeat edges, that's what I mean. And so it's repeated that edge there. So that's out too. So C is the answer. Okay, shortest path from A to C. From A to C. Shortest path. Okay, let's do a bit of trial and error. Let's go the most direct way. ADC has a total of 12 and 8 is 20. We can go this way. So A, D, B, C, 12, 16, 19. Okay, and there's possible another way too. Having a look here, you can go around the back way. A, E, D, B, C, 5, 11, 15, 18. And I think going from A, we've gone to D twice, and E. If you go this way, that's 12, so we're not going to get any shorter. So that's the one, 18. Okay. Next one is minimum spanning tree. Okay. Let's just need a bit of space for this one. Minimum spanning tree, I'm just going to label the vertices, makes it a bit easier. Of this, minimum spanning tree must cover every vertice. There can be a B there. C, D, E, F, and G. With the minimum spanning tree, we can leave out edges, but we've got to get to every vertice. So let's put them all here to see if we cover everyone. Sometimes the process of elimination, let's have a look. I'm going to start with A and go to B. So A to B equals 2. Now there's no other. Yep. So A and B are covered. With minimum spanning trees, we've got to check out the shortest weight from each vertice. Now covered A, there's no other one from A. So B, we've got a 4, a 6, or a 9. So B to C is the least weighted one. So B to C is 4. B to C is 4. Now C is covered. Yep. Now we've got to just go look at B and C again to see which one is the least weight from C or B. So we've got to examine each vertice that's already been covered. So we've got a 5 there, 6 and a 9. So 5 is the least weight. So we're going to go C to D, which is 5. And that means D is covered. Okay, now where do we include all of these to see which edge is the least weight from each vertice? Now going from D, we've got a 7, a 10 and a 4. We've got a 6 and a 9 from B, and C is covered anyway. Okay, so we can go, the 4 is the least weight from D to E. Equals 4. So that will go that way. So now we've covered everyone except F and G. Okay, so now looking at B, C, D and E, which edge, well C's out. So we've got and D, we've got 2 more from D we can use, and 2 from B. Which edge is the least weight? So looking at D, we've got a 7 and a 10. B, we've got a 6 and a 9. But looks like 6 is the least weight, but we can't use 6 because we're not allowed to create a cycle, a loop, a cycle. No, cycle is the technical term, but can't do that one. That will create a cycle. So we have to go with D to F, the 7, D to F. That's the least weighted one that won't create a cycle. Yeah, the 7. Now, we've got one more. Least weight edge from B. Can't do the 6 one, so that's 9, 10 and an 8. So it looks like F to G is the least weight of 8. And that means G is covered. So now every vertex here is touched, which is what we want, with no repeated edges and there's no cycles. So that's it. So now we have our minimum spanning tree. And we just add these up. And what we get? 8, 7, 15, 19, 24, 28, 30. 30 is the length of the minimum spanning tree. Okay. And now, question 8. The length of the shortest path from the bottom vertex to the top. We're just going to get rid of our spanning tree. Oh no, I'll do a different colour. Well, we can go from A, the bottom vertex to F. A to F. We can go this way, 2, 4, 5 and 7. What's that equal? 22. We can go 6, 4, 7. What's that equal? 17. 6. Oh, plus the 2. 19. Sorry, I forgot about that little 2 there. 2, 6, 4, 7. 10, 12, 19. There are only ways that are shorter. 2 and 9 is 11 and 8 is 19. Sorry, 2, 9, 2, 9, 8. 17, 19. That's the shortest. Looks like 19 is the shortest. 2, 8. 2, let's try this way. 2, 6, 11, 18. 18. Oh, we found one. A, B, C, D, F. 2, 6, 11, 7 is 18. There we are. 2, 4, 5, 7. 6, 11, 18. 18 is the shortest path. There we go. Thank you.